Okay, today we're going to talk about how to draw a covalent compound, this Lewis structure of a covalent compound. I'm going to give a couple of examples first. We're going to do the example of, first we'll start with chlorine, and this is diatomic chlorine. Then we're going to go to nitrogen, and then carbon dioxide. Alright, the first one, chlorine. When you're drawing a covalent compound, you're first going to write down the name of the element with the right number of dots for how many valence electrons there are. Chlorine has 7. 1, 2, 3, 4, 5, 6, 7. Then you're going to draw the next element. 1, 2, 3, 4, 5, 6, 7. Now comes the fun part. We're going to connect the dots. You have this dot and this dot. We're going to connect these dots. This means that these electrons are being shared. Neither one of these elements can take away that electron, so it is not an ionic compound. It is covalent, which means that the electrons are shared. So we connect the dots, which means 2 electrons shared between them. But now we have to rewrite it. So we're going to redraw it with the number of dots. This one had 2, 4, 6. So we have 2, 4, 6. Then we're going to draw that line. We're going to make it look neater. And then I'm going to write the other chlorine on the other side. We have 2, 4, 6 electrons. So that's 1, 2, 3, 4, 5, 6. Now when I count these electrons, I have 1, 2, 3, 4, 5, 6, 7, 8. That counts as 2 electrons. One line equals 2 electrons. So this one has 8. Then we go 1, 2, 3, 4, 5, 6, 7, 8. Second chlorine is also good. Now let's do nitrogen. And we're going to look. First of all, nitrogen, we're going to draw it. Has 1, 2, 3, 4, 5 valence electrons. This other nitrogen has 1, 2, 3, 4, 5 valence electrons. Now I'm going to connect the dots between the nitrogen on the left and the nitrogen on the right. Connected 1 dot, connected 2 dots, and connected 3 dots. We're not going to connect these dots right here because they're already set up in groups of 2. Now we're going to redraw this, and we're going to redraw making the lines neater. We have 1, 2, 3 lines. So there we go, 1, 2, 3 lines. And we're going to add the leftover electrons. So that's 1, 2, 3, 4. Now let's check our work. We have 1, 2, 3, 4, 5, 6, 7, 8. This one checks. 1, 2, 3, 4, 5, 6, 7, 8. That one checks. Looking at the next one. So carbon dioxide, you're going to notice there's 1 C and there's 2 O's. So anytime you have one element and then a bunch of other elements, like 1 carbon, 2 oxygens, think of it like a Christmas tree. The Christmas tree goes in the middle, and the other elements go off to the sides. If you had 4 oxygens, 1 would be at the top, 1 would be at the bottom. But we only have 2. So each one of these, we're going to draw the number of valence electrons. 1, 2, 3, 4, 5, 6 for oxygen. 1, 2, 3, 4 for carbon. And that last oxygen is going to get 1, 2, 3, 4, 5, 6. Now let's connect the dots. I have 1, 2 leftover electrons here. There's 1 line. There's 2 lines. Now we're going to connect the next carbon and the next oxygen. There's 1 line. There's 2 lines. Now we have to redraw it and make it look neater. C, 1 O on each side. If you look, there's 2 lines going between the carbon and the oxygen on the right, and 2 lines going between the carbon and the oxygen on the left. Now as we look, we have 4 leftover electrons, and on the right side we have 4 leftover electrons. Now we're going to verify the number of electrons on each element. On the oxygen on the left, 1, 2, 3, 4, 5, 6, 7, 8. Check. Carbon, 1, 2, 3, 4, 5, 6, 7, 8. Check. Oxygen on the right. 1, 2, 3, 4, 5, 6, 7, 8. That also checks. This is carbon dioxide.